Hello and welcome to this video. So before we get started with the actual content, I thought I would just introduce what this is. And this is a segment from a course that I created for the website Udemy, which is a introduction to Git, GitHub, and GitHub Actions, and how these three tools work extremely well together to maintain version control over repositories, and also for CI pipelines and software development teams. These three tools are very useful. So it's a course that introduces these three tools. If you've never worked with them before, or you want to look into them and get an idea of how they work, you can find that course on Udemy. It's entirely free. So I've linked it in the description below. The entire course is also available here on YouTube. I've also linked a course that I created that focuses specifically on GitHub Actions. So if you want to dive deep into GitHub Actions itself, you can find a link to that course in the description as well. So I hope this video will be very helpful for you, and if you find the content is useful, please do like the video and perhaps subscribe to the channel to look for more course content in the future. Hello and welcome to this section all about Git. So in this section, we're going to look at what Git is, how it functions, and the benefits that it offers, and then you're going to have a chance to make use of Git on your local machine. So we'll start playing with some Git commands and things to create some files and also save files and then change files and all sorts of things, just to give you a little bit of a taste for how you can use it on your own computer. So let's jump right in and get started. Hello and welcome to this lecture. Now in this session, I would like to introduce you to the concept of Git, what it is, how it works, the benefits it has for you as a user and also as a team within an organization or a team working on a project. So let's get started and dive into what Git is. So that brings us, of course, then to the first question. What is Git? Git is a distributed version control system. Fancy words, but it's really just a creative way of saying that it helps you do the following. You can track changes in your files over time. You can collaborate with others by sharing and merging your code. And you can roll back to previous versions if something goes wrong. So let's explore these three ideas in just a little bit more detail. You can track changes in your files over time. This means that when something is changed in your code, Git doesn't just erase the previous version and it's gone forever. That previous version still exists within your code space. It's not necessarily the most current version of your code anymore or the latest version, but it's still there. It doesn't get removed. It's sort of always around. Now, in terms of collaborating with others, because Git is essentially an online system, you can work on the same piece of code from pretty much anywhere. So you might have a team that's all based in the same office, or you might have a team that's based across the entire planet. You can all still work on the same code and you can work on it together. And then the third point, this ties in quite nicely with point one, which is that you can roll back to previous versions if something goes wrong, because your code isn't, the older versions of your code aren't just removed entirely. They still exist. They're just not necessarily the most current one. It is possible to go back to those previous versions. And this is what makes version control so useful. So seeing as we're talking about version control, why is it that we need version control, particularly in our modern day environment? Well, imagine you're working on a coding project and you want to keep a history of your work. You want to test new features without breaking your main code. And you want to collaborate with teammates without accidentally overwriting their changes, right? Version control solves all of these problems. It's like having this infinite undo button for your code, plus you have a collaboration tool that's all rolled into one. Now, let's say, for example, you make some change to your code, which you push to the main branch of that code, and it breaks your tool or whatever it is that your code creates. Now, without version control, you'd be stuck. You'd have to then work on something new to fix that problem. And until you fix the problem, the code remains broken until you push a new change, which hopefully will fix it. But with version control, that's not the case. You can essentially just roll back, go back to the previous version of that code that wasn't broken. So if you made a change and it breaks this tool that you're using in some public environment or your users are making use of and it doesn't work, rather than then trying to scratch your head and figure out a fix very quickly, you can just say, right, let's go back to the previous one because that actually works. get it working again for your users, and then you can focus on fixing whatever the problem had been in the first place. And this is why I say it's like having an infinite undo button. When you make an error, you can just go back to a version of the code that didn't have the error. Now, Git does have other ways that you can avoid making a change that breaks it from the get-go, like stopping it before it even gets to the main branch. And we'll talk about that a little bit more very soon. But this is really just to explain why version control is so useful and why in today's world we really need it. Okay, so how does Git work? Well, let me go through some terminology for you. Git is made up of repositories, and a repository, or a repo for short, is a storage space for your project. It contains all your files, all the code that creates whatever it is you're creating, as well as a history of those changes. So all those older versions of your code, they all exist within this repository. It also has snapshots, and these snapshots are essentially the older versions of your code, right? Git records snapshots of your files, not just the differences, the actual files themselves. So each version, each change creates a new snapshot, a new complete version of your repository that is current at that particular point in time. Now, third, we have one of the more useful features for testing something that might break the code, and that is branches. You can create branches that you can use to experiment with new features or ideas or changes to the code that you might want to make. When you're ready and when you know that they will work, you can then merge those changes back to the main branch, the main code of your repository. In the same way, if the change doesn't work and you decide to abandon it, you can just delete the branch, and the main branch, the main version of your code, was never affected. And finally, distributed nature. With Git, every developer has a full copy of the repository and the history of that repository, no matter where they are. So this makes Git fast, reliable, and perfect for remote collaboration. In fact, most recently, some text editors allow multiple users in different parts of the world to look at the same session, the same piece of code on the same screen at the same time, and you can literally work on it together at the same time. It completely eliminates the barriers of distance. You can be anywhere, and as long as you have a connection, you can work together in real time. So, what are some of the benefits of using Git? Other than the fact that it is the largest tool for this sort of use in the world right now, here are some other benefits. The history of your changes. Every change you make is saved, so you can track what changed, who changed it, and when. We've mentioned this a few times now, but collaboration. Git makes it easy for teams to work together across different locations across the planet. And maybe one day across different planets, who knows? Branching and merging. Experiment freely without affecting your main code using your branches, right? And then when your new feature is ready, you can merge it with confidence that it won't break your code. Speed and efficiency. Git is lightweight and it performs most operations locally, making it fast and efficient, locally being on your local machine. And finally, widely supported. Git integrates with countless tools and platforms, including GitHub, which we'll learn about later in this course, Bitbucket, and GitLab. So, here's a real-world example for you. Imagine you're building a website and you want to use Git to build that website. Well, in that case, you can use Git to save your progress as you code. You can try out a new design on a separate branch without affecting the live version of the site. And of course, you can collaborate with a teammate who's working on the back end while you focus on the front end. You're changing different things in the same repository. If something breaks, you can quickly revert to a previous version and figure out what went wrong. So you're pretty safe. Now, just some misconceptions that I would like to clear up. Is Git only for programmers? No, it is not. Writers, designers, anybody who wants to manage files can benefit from using Git. Secondly, is Git hard to learn? I would say not at all. It might feel unfamiliar at first, as any new tool does or any new language when you're learning it, but as you practice, it does become easier and eventually it becomes second nature. And finally, do you need to memorize commands? You definitely don't need to. You can look up commands, and there are tools if you prefer a point-and-click experience. Memorizing commands, of course, is helpful, but it's certainly not a necessity. And that's it. That's our basic introduction to Git. In the next section, we're going to get hands-on and start playing with it, seeing what it can do, and learning some commands that you can use with Git. I'll see you there. Hello and welcome to this lecture. Now that we've looked at what Git is, let's get hands-on and play with it a little bit on our local system. So what we're going to do is use Git commands to initialize a repository on our local machine. And then we're going to add a file to it and see how we commit that file to the main branch, if you will, the main version of that repository. Now, before we get started, it's good to make sure that you definitely have Git installed. We covered this in the third lecture in this course, but if you want to confirm, you can type git -- version and you can confirm that Git is installed. If it is not installed, make sure it is, because if it's not, you cannot do anything that we're going to do in this lecture. Now, I'm going to create a folder where I will initialize this repository. So the commands might be slightly different depending on your operating system. I'm on a Mac, so I'm going to use the make directory command, mkdir, and I'm going to give my folder a name. Let's call it Git course. And now I can use cd to navigate to that repository. So now I'm in the Git course, well, not repository, sorry, folder. Now I'm in the Git course folder, but now I want to initialize a repository there. And in order to do that, we'll use the git init, which is essentially git initialize command. So git init like that. And you can see that now a empty repository has been initialized. And there's a slight change now. You've got dark blue git with main in red in brackets. So now we've initialized Git, and main refers to the branch. We're on the main branch of this repository. So now that we've initialized our repository, let's type git status. So that will just be git status like that. And we can see that we're on the main branch and there are no commits yet. There's nothing to commit. That's because there's nothing there, right? We don't have a file. We have nothing. We've just initialized our repository. So let's add something to this repository so that we can commit it. So what I'm going to do is I'm going to just create a basic text file, which on Mac I can use the touch command, and I'll call it new file.txt. So now I've created, if I run an ls command, we can see there's our new file sitting there. So what I'm now going to do is I'm going to add that file. I want it to be made available to be committed to this repository. So to do that, I will use git add. And then I'm going to put the name of the file, which is newfile.txt. And there we go. So now that we've run the git add command, let's rerun git status. And now you can see there's a slight difference. We're still on branch main. There's no commits yet, but there are changes that can be committed. Something's been done, right? We have a new file that's ready to be committed to the main branch of our repository. So how do we do that? Well, to do that, we'll use the commit command. So to do this, we'll say git and then commit and then m, and now you pass a message. This can be whatever you want it to be. In my case, I'm just going to say add new file.txt. And now when I press enter, you can see now a file has been moved. It's been added. So if I now do git status, we have nothing left to commit, right? There used to be, there was a file ready to commit. It's no longer there. So let's do git log command. And here we can see that a new file was added recently. So that's a very basic way of showing you how you can work with Git on your local system. So let's quickly recap the commands that we covered here. We started with git init, which when you're in an empty folder will initialize Git within that folder so that you can essentially turn it into a repository. Now after that, we ran the git status command, and the git status command will tell you a few things about your current status. What branch are you on? Are there any changes waiting to be committed to the main branch? Things like that. Now, once we were done with that, we created a new file, and then we used the git add command to add that file to the repository. We're essentially preparing it to be added to the main branch of that repository. And when we reran git status after that, we saw that there were changes to be committed. A new file was ready. So then to actually commit that file to the main branch, we use the git commit command, which is git commit -m, and then the message that you want to pass. And finally, we used git log to see a log of what we had done. So that's a very basic introduction to some of the sort of starting commands that you'll use to get Git up and running on your system. Now, in the next session, I'd like to look at how we can work with branches. Branches are very important for testing changes, so we want to know how we can do that. I'll see you there. Hello and welcome to this lecture. Now, in this session, I'd like to talk a little bit about working with branches and also show you just a bit of hands-on how you can create branches and play with them yourself on your local machine. Branches are an essential way to collaborate with other teammates and to propose changes that you want to make to the main version of the code. So understanding how they work, what their benefits are, and just getting a bit of a feel for how to work with them is very useful. So let's take a look at branches and how we can play around with them just a little bit. So what are branches? In Git, a branch is essentially a pointer to a specific commit. And what that means is when you create the branch, it takes the code that exists from your base, from the point at which you're creating it. Let's say you're creating it from the main version of the code. It takes that code that exists at that point and it copies it to another place, another branch, where you can then manipulate it and play around with it, make changes and test things and so on without touching the main code that you had essentially copied. You can therefore create a branch, make your changes, and then once you're happy, you can merge those changes back to the main branch when they're ready. So at that point, it would overwrite what's on the main branch with your new version of the code. So why would you use branches? Branches solve several key problems or potential issues in software development in particular. And they are the following. First, isolation. You can work on a new feature or a bug fix without disturbing the main code. You can test it, play with it, make sure it works on a separate branch and the main code is not affected. Collaboration. Each team member can work on their own branch, and this makes teamwork pretty seamless. It's even possible to work on the same branch if you want to. It helps with organization. Keep your work structured. You have separate branches for, say, features or fixes or experiments. You can create a branch for anything you want, really. And finally, rollback safety. If something doesn't work out, you can delete the branch without impacting the main code. So if you're creating a branch to test something and it doesn't really work, you haven't broken the main code, you can just delete your branch and start over if you want to. So let's play around a little bit with creating our own branches and making some changes and then taking those changes and sending them to the main version of our code. So I'm in my terminal on my PC and I'm in the same folder that I was in previously, the Git course folder, and Git is initialized and I'm on the main branch of my repository on my local machine. And if we do an ls, we can see the same file that we created in the previous lecture, the new file.txt file. So first thing I'd like to do is show you how you can create a branch that takes the existing code and copies it to that branch. And we can do that with the git branch command and then the name of the branch. Let's call it branch 1. Now you'll notice there's been no error, no response, so it seems to have worked, but you still see main here. That is because even though you've created that branch, you're still on the main branch. It hasn't moved to that branch yet. If you want to move to the branch that you've created, you would use the git checkout command and then the name of the branch. And you'll notice when I run this, it's now switched and now we're on branch 1. Now it is actually possible to combine these two steps into one command if you want to create a branch and move to it immediately. And this can be done with the git switch command. So if I check out quickly, back to main, if I can just spell, I go back to main branch. And now I'm going to use git switch and then -c, and then you enter the name of your branch. Let's call it branch 2. And now you notice that it's created a new branch and then it immediately switched over. So if you're working from scratch and you haven't even got the branch yet, git switch -c will do the job. If you already have a branch, you can use git checkout just to move to that branch. And if you only want to create a branch but you don't want to do anything with it yet, you can use git branch. You won't move to it, but it will exist. So we're on branch 2, which means now anything I do will happen on this branch, but it won't happen on the main branch. So let me create a second file. Let's call it new file 2.txt. And now if we do an ls, we can see we have both files there. Now, this file is on my new branch 2, but it's not on the main branch yet. So what I'm going to do is I'm going to add my changes, and I can use dot, which will add any new changes that have been made. And if I do git status now, I can see that there are changes waiting to be committed, right? The new file is waiting to be committed to branch 2, not to the main branch, to branch 2. I'm on branch 2. So let's use the git commit command that we learned about in the previous lecture and say add file 2. And now we've committed a new file 2 to this branch. So branch 2 is up to date, but the main branch is not up to date yet. In order to update the main branch, I need to merge this second branch that I've created to the main branch. In order to do that, I'm going to check out my main branch again. And now I'm going to use the git merge command and enter the name of the branch that I want to pull changes from. So I'm on the main branch. What branch do I want to go and fetch changes from? And that will be branch 2. And you can see now that a new file has been added. And so now the main branch is up to date. Both files are there. The main branch is the latest version of the code now. So this is just a simple introduction to how you can play with branches on your local machine. Once we introduce GitHub and you're starting to work with other team members and other collaborators, the process will change slightly. You wouldn't just merge things to the main branch on your local machine. It'll be a little bit different, and we're going to see how that works in the next section. Let's just take a moment quickly then to refresh the commands we have learned about here. We started with git branch and then your branch name, which will create a branch but won't move you to that branch. We then learned about git checkout and then the branch name, which will move you to an existing branch. And finally, we learned about git switch-c and then the branch name, which will both create and move you to a new branch. After that, we played with some commands we already know: git add, git status, and git commit from the previous section. But there is one new command here at the end, which is git merge. And this is where we fetch changes from another branch, and in our case, we merged it to the main branch. And that brings an end to our basic introduction to Git on your local machine. There are, of course, plenty of resources out there in the world and on the internet that can take your knowledge and your hands-on exercise and experience with Git way further, and I highly encourage you to do so. The point of this section was just to introduce you to the concept and let you play with it a little bit. Now in the next section, we're going to introduce GitHub. And then we're going to start seeing how GitHub works with Git so that you can propose changes to your team or your other collaborators before merging them to the main version of your code. I'll see you there. Thank you for taking the time to work through this video. I hope that you found it particularly useful. Remember, the entire course is available here on YouTube and also on Udemy, and I've linked the Udemy one in the description below. You can also find my course on GitHub Actions on Udemy if you're interested in diving deeper into GitHub Actions. If you enjoyed this video, please consider liking the video and perhaps subscribing to the channel to look for future updates. Thank you so much for your time, and have a lovely day further.